Hello everyone. So we will take some look at the array questions. Let's start by maximum active ones. So given a binary array nums, return the maximum number of consecutive ones in the array. What does it mean? Here are ones 2 times occurring, and after 0 there are 3 times occurring ones. So maximum number of ones that are occurring together are 3. So output is a 3. So let's open actually draw. For the drawing, let me remove this one out. So how would we solve this? So one way to solve is that having a for loop. Let's draw the diagram as well. 1 1 0 6 elements. So 1 here. So 1 1 1 0 1 1 1. So one way to solve is that to have for loop. Let's point here. This is our I. Okay. Uh, so this is our I, and we can have a variable count that will be initialized to 0. So initially the count will be initialized to 0. So when we found 1, we will increment it each time. Let's say the I gets here. So we will increment the count by 1 each time we found 1. So now we will have a count 1 here and 2 here because we have found 2 1. When any 0 is encountered, we will just do nothing, skip until we find the 1. When we encounter 0, we have a previous encounter variable. I think we need one more variable as well, which is the previous count. So show the previous count. And Now we will have previous count and count is initialized to 0 again when we encountered 0. So now the I gets incremented again. We will have the count again, and now we will have a count 3. Okay. So when we reach the end or encountered any another 0, we will compare when the I gets out of the loop, or let's say we have another 0 here. Yes, 0. So what will happen that time is that if the previous count variable has some value, then previous count will store the maximum of the count and the previous count. What will be the maximum? Will be the result stored in the previous count variable. And we will return the previous count once it's all being done. So when I comes to the 0, again it will have this. Before, when we encountered 0, we have not changed the value. We have just changed the value because there was 0. So 0, maximum 0 to 2. And same here we can do this. So the time complexity and space complexity, what will be space and time complexity? Space complexity will be O of 1, because we are using two variables, we are not using extra space rather than the two variables. So we will have space complexity of 1, but time complexity we will iterate through each time and then saving the count. So we will have time complexity of n. Also, if we look to the constraints as well, it raises that num's length is lesser than equal to 10 raised to power 5. So I have this diary. It have the 10 raised to power 8 operation rule written to it. So according to this, the maximum we can use is of n cube or n square, the maximum that we could use here. So according to that, our solution is optimized. Let's try to code this one. For int, yeah, for int I is equal to 0, I is less than nums dot length I plus plus. Let's take the variables. So we have two variables, previous count and count, and a for loop int I is equal to 0, I less than nums dot length I plus plus. So let's iterate through this. If nums of I equal 0, then previous count equals to math.max of previous count and count. Okay, else previous count value will be changed, but we have not changed the value of count again. So we will have count else count plus plus, and we will have this line again after the for loop as well, and then return the ref count or previous count variable. So why did we added this line? It is to store the last count here. Let's erase this part here, and now when the I goes out of the loop, we do not have any zero. So we had at that time still count is equal to 3. Okay, so we have to compare these two counts at the last. So, but the for loop but the I is now out of the loop. So we cannot do this in the for loop. So we have to do this after the for loop. So let's check if our solution is correct. Accepted 0 milliseconds, and let's run it. 2 milliseconds beats 90% of users with Java. So there is an optimized solution as well. So let's see that what can we. This is the same solution. Yeah, same solution. If I run it again, maybe we will have 1 millisecond response. No. Sometimes it does that, but we have fairly good solution. Another solution with 3 milliseconds time. Okay, this is our same solution, but with 3 milliseconds time. So let's change the question right now and add this to my repo as well to keep a track of these questions. Max consecutive. Let's clear it and have this and do this way. Max consecutive ones. So now we will put it in our repo. And now it is triangle. Okay, so let's put this out. Edit max consecutive one solution and commit and push. Okay, no problem. So it is pushed to my repo, and now we have some this question. The next one we are gonna take a look at is maximum subarray of size. Maximum sum subarray. Let's find it. You are given an integer array nums and integer k. Find the maximum subarray sum of all the subarrays of num that meet the following. The length of subarray is k and all the elements are distinct. So number is 1 that's taken in the input. Number is 1542 triple nine k is equal to 3. So I understood the question. Let's okay. So let's draw the diagram. We have let's partition this. By 4, 2, 9, 9, and 9. So now, firstly, we will have this. We will do this part here. Okay. After each iteration, it will be like this. Move by 3 bits here. This, this. Okay. And we will have like this going on. If we are out of index, then break. So we will find the sum of these one, this one, and this one. But we have to also make sure that the elements are distinct every time. So how can we find that the elements are distinct or not? So it would take us two loops to do this part here. one loop iterates through this window. So by the way, it will use a sliding window algorithm. So let's write here sliding window. Okay. So we will have two variables here, I, and there is also j. I and j. So they will move like this. Firstly, it will be I will be 0. Firstly, I will be 0 and j will be I plus 1 plus 2, or the j will be equals to k every time, I plus k. So now we will have this, and we will find the sum here, and find if they are distinct or not. And we will have this, 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 and this. We have to also make sure they are distinct elements. So how can we make sure? In the second, this is the first for loop. Okay. So in the second one, we can do is having a map here. Uh, key and value, and we will have 1, 5, 4 here, and their respective count. And we have to make sure that each count is 1. Oh, sorry. So we have to make sure that each count is 1. So in the key, we will store the elements 1, 5, and 4, and we will have count stored on the value 1, 1, 1. And it will be done for all the pairs. So let's move it and see. Now I have moved this one. Okay. So as we are moving here, what will happen is that the value gets changed. So now we will have the 5 to 4 here. Let's write the 5 to 4. And 5, 4 to. Now it gets move along. And now we will have 4 to 9. Okay. So let's move along to 9, 9. Here there is an anomaly. Yeah. So let's move to this here. So we will have 2 occurring one time and 9 occurring two times here. So as soon as we see this possibility, we will skip this pair and move to the next one. And now move. Now we will have 9 three times. Okay, so now we have 9 three times. So we will still move until we have reached the end of the array. Okay, this part is covered. Let's get back to the original part here. Yeah. So now each time we will finding that every element has one value. We will also have a variable to store the maximum, to store the sum here. So we will have a variable maxsum equals to 0. And after we have found a successful pair that matches the criteria, we will add all its value to here. We have 5 plus 1 plus 10. And as we are moving along, we will adding the value if we have right, if our pairs are matching the criteria. If they are not matching the criteria, we will not add the value to the maximum here. So we will increment plus maximum. Sum of our pairs plus maximum. So this is the work criteria that we will follow here to do this question. So let's try coding it right now. So first we have to create the for loop here. Int I is equal to 0. I is less than nums dot length I plus plus. Okay. So we can have int j equals to I plus k. Let's do while loop. Will be more easier to see. Int j is equal to I plus k while I is less than nums dot length and j is also less than nums dot length. Okay. Then I plus plus and j plus, let's I plus 1 and j is equal to I plus k. This is our increment statement, and now we are at this pair. Let's so now we are at this square pair. We will have our start index as I. Let's call this start and end. It will be more good here. Will do good. Start plus a and end. So now we are at this. So now we will have a variable like this. MaxSum equal to 0. Addition of pair and start and end. Now return -1. We will take a map of integer. We could also take an array if we want to, but I am for simplification reasons taking a map. By the way, this approach takes time here, space here. So map dot condition for invalid pair count equals to 0, and we will entry dot get because we have keys over here. And we will return the count here. If there is an invalid pair, do not add it to the result. So we can have this else we'll add it to here max sum condition, or we can have this greater than 0 condition. And at last return the count here. So let's take start equals to 0. Okay, and end equals to this. So when start is lesser than and end is equal to, when the both condition is true, we are finding the addition of the pairs, and if there is an invalid pair, we are just, but we are not currently saving it anything. Okay, so let's save it for int I is equal to start, I is less than end, I plus plus, and then map dot set and nums of, we have to also pass nums as well. Nums of I dot get or default. So we pass nums I and default 0 plus 1. This will set the map value here and map dot set. If this function will what will have is that the first argument it first checks if this value is present or not. If it is not present, it will save the default. It will return a 0, and then we are incrementing it as 1 and saving. So our final result will be like if 9 is encountered one time, it will be 1 only, and if 9 is encountered two times, then it will fetch the value of that is currently in the this key. So it will be 1, and now it will increment it by 1 itself. So we can have this as well, but I am going with the 1 here. So I think we are good to go. Let's try it out. Okay, so here is a small mistake. Okay, nums here. Okay, we will also have another error, max sum, and we are saying it as count here. So let's have it in the long. Long, long, and then everything looks good. I think it looks okay. Dot put function, I got it. So we have passed this one, we have failed this one. The expect is 15 and output is 36. Okay, so now I understood what is the problem here. We are incrementing it, but we are not gonna increment it. My mistake. Max of we are get no, we have to get the max of. So we will have this max sum and the count here. I think we are good. Yeah. And we are under the time complexity as well. 48 of 93 test cases passed. Use this test case. Output is 16 and expect is 22. Why? That means we have this here 7, 8, 9. We'll first close with this, with this. 1, 1, 1, 7, 8, 9. First we have this Then we will have this not applicable. So we will have this here, this here. We have only two pairs here. So we have 7 able teams. Okay. And we will have 7, 8, 9. 7 plus 8 plus 9 equals to 24. Okay. So we are missing something here, I think. First two, I think we are missing. Yes, we were missing less than equal to. Wow. So we had a TL here. Interesting. How much cases we have passed? We have passed 63 out of 93. Okay, so how can I optimize this as well? Our solution is right. We had encountered TLE error. So it is taking a set okay. Instead of this for loop going on here, instead of all this and having the map here, we could switch it to the set. Why I have not seen this before? Hash set set dot add num I. Okay, so we will have num I here, and we can avoid this for loop. It does not change the time complexity, but maybe it will have some impact on the compiler. So we will remove this code, and yeah, before removing it, let's add the code here. If set dot hash size is size equal 3, then we are having distinct elements, else we are not having distinct elements. So this is the case here. Now let's do it. Let's try it running it. Okay. Lesser than 3 return -1. Okay. Let's plug the instances. It will find the sum and add to the set, and if the set is less than 3, then it will return us -1. So we'll plug in the. I think it has been fairly improved. If I am just put fully connected, and now, so what's the issue here? We have output 0, but expected is 3. Why? K is 2. So we will have 1, 2 and 2, 3. Okay. We have why it is going for this circuit. Okay. So lesson K. So find the K also. Before we do not need to find the K. But now we have to pass the K as well. The K can be changed. I think we are going right now. Yes. TLD error. I understand this part here. For this is because this is what I was doing as well. If HP dot size equal k, answer is equal to mat dot max answer or sum. Okay, so we are using this. This part I totally understand, but it is incrementing the sum along all the x. So if int I equal to k, I less than n, I plus plus, this is fairly complex means, and this is complex. This part I am not able to understand here. What is this going on? So what I have seen is that there is some sort of operation going on which can convert this of n square elbow to this of n. But according to using set, let's remove this solution. I have understood what this means also. Yeah. Let's try this one. This is our solution, which is the O n square, and we have the O n space as well. And let's see its solution. Now, okay. So this is the solution here. Let's do this our case. So it's started 0 milliseconds and then split. Oh, so what's happening is that it is O n solution with amortized O n solution. Why amortized? Because to have this run, we have to match the certain criteria, which is that number already contains this and the size equal to k. Then it will remove all the elements here that we do not need, and otherwise it will just work like the previous one. This part here does all the work. This is the amortized solution. Amortized, or I would say it like, but if every number is the same one, for example, 444, 999, and 9 6 times, 9 10 times, then it will go n square time only. But we had O and n square time complexity every time, but it will have for some cases. So that's the difference why our code was having the TLE errors. So we have solutions like this coming up in 29, 28. Let's see the 28 second one. So we have no amortized for loop as well solution to do this part, and my God, I think this is probably the best solution that I've seen. I'm confused. If right is less than 11. Okay, so right is less than 11. Okay, it is there. Right, so it's okay, alright. So let's chat the it and on this explain this. So we have initialized variable pointer for sliding window, left and right, ransom and answer so far. So we are looking through this array, we are finding new number current again being considered and अगर वो पहले ही है तो हम क्या करेंगे करंट सम में उसको प्लस कर देंगे लास्ट element is already present in the window ठीक है it is the window previous this window get position okay so we are using map to check this. Okay, so what I have understood, it combines the running sum problem and according to this working and using the map to get the position where the element is created. And then combine the running sum here and this is the part where we shrink the window and okay, I understood the solution. So I will take a pause here and come back.